I guess. Okay, thank you, Jason. Very cool.
No problem.
Okay, so basically, disclaimer, I was supposed to give the second part of this lecture. We are waiting on the guy who was supposed to give the first part of the lecture, but I will go ahead and get started. Okay, I guess this is like administrivia or something.
Michael, are you sharing your screen?
Oh, I'm not on Zoom. Whoopsie. Let me how do I use Zoom? Let's see. Share screen. Host disabled participant screen sharing.
Oh, hold on.
Damn.
Yeah, it's a rig. It was rigged from this. I like the button feature. Oh yeah. Oh dude, whoever's running that media account is fucking hilarious.
Lovely.
Give another shot.
Yeah, works. All right, there we go. We'll just slideshow it. All right, does this work, guys?
Yep, we can see it.
Okay. So I'll actually skip the second half of this lecture. Because the process guy is not here yet. Yeah. We will start with system D. There we go. What is a service? Okay, so yeah. All right, I guess I'll you like to run it on processes. Like a process is like the basic unit of execution on an operating system. Have you guys taken like 61C? Yeah. 162? Yeah, okay. I haven't either, but yeah, it's basically like the like basic unit of execution on an operating system. They can be scheduled by the scheduler. They can run instructions out of order. Like a process can like spin out multiple threads, right? And you can also have like multi-process coordination. You learn that 61C. But a service is just like a type of process. You can run it on any operating system. It's called a daemon. Basically, it's just like a thing that runs in the background. It's called like a headless process. You've probably heard of that. Like you can't like click on it, right, or anything like that. You basically have to use like commands to like interact with it. Like in this case, using systemctl on Linux. So yeah, they're controlled by what's called an init system, which is a thing that manages background processes. Yeah, and here are some examples of different daemons. So SSHD, HTTPD. Usually if you're like a sysadmin and you like install a background process, a lot of the time it'll end with D, which just stands for daemon. As it says right here. And yeah. And yeah, again, it's not really a strict definition, but yes, like you can like start something like in like a tmux terminal. Have you guys learned tmux? Yeah, and it's like and like detach from it, and like you could like loosely classify that as a daemon, I guess. But yeah, services are good because you can run them for a long time. Web servers are an example. They can they can be like publicly accessible or shared between multiple users. Have you guys used systemd yet in lab? Well, basically what this means is like, for example, like SSHD is a service that's like running globally on a server, and like any user with sufficient permissions could be like, hey, I want to stop this service or like start the service. So it's not running under like any specific user, at least for a system process. So yeah, SSHD is the example given here, and you can also write your own. Yes, again, systemd is the init system. It just stands for system daemon. Yeah, and then yeah, the actually important thing is the two tools that you'll use. So systemctl, journalctl, those are like the two commands that you'll be typing a lot of the time on Linux. And yeah. Basically the way you make a systemd service work is you create what's called a unit file. And then you put that in the appropriate directory, and you can be like systemd will be able to like find it by name. So like, you put it in the right directory, and you can be like systemctl like start like the name of the service, and then it'll just like start it And you can do like systemctl enable the service, and then it'll start like every time you boot. So you don't need to like worry about anything like that. So yeah, this is an example of the syntax. It's like pretty simple. It's just like what command you run and what user runs it. Yeah. Yes, and then we go through these things. Yeah, so it's just a descriptor of like what you want the process to do, like what executable it is, and like when it should run. Yes, here's an example of Nginx. Have you guys learned? Yes.
Can you specify like more, I guess, either stringent or general conditions, like I want this instead of user, maybe group or
I believe it has to run under a user. That's
yes.
yeah. Although yeah, like my past use of systemd has just been like little services that run under one user, but you should be able to set permissions on like who can start and stop them. Would you like to clarify, Albert? Have you ever set group permissions on a unit file? I'm like pretty sure it's possible, but I've not done it myself.
I have not done so.
Okay. Here's an example with Nginx. Have you guys used Nginx? Basically it's just like a thing that will receive like URL paths and like based on the URL path, like return something or like forward it to another process. So
I think take over this slide to the system. I can probably take over now.
the systemd part? Sure, if you want.
Okay.
I haven't done the process part yet. I just started. Okay. So systemctl is essentially just a list of things, like a list of all the services that are currently running or that have currently failed. Essentially everything that is loaded is going to show up here, and as well as some cursory information about their statuses. If you want more detailed information about the status of a service, you should do systemctl status and then the name of that service. For example, for Nginx, we see nginx.service, a description of that thing, as well as loaded, whether it's active, what the main pages or whatever are, the main PID, number of tasks, and the group of processes. So there can also be like logs, depending on your version of systemd. There's also a couple other systemctl commands that you should probably know. For example, systemctl start, stop, and restart are pretty intuitive in that they start, stop, and restart the service. Reload essentially means that you are reloading the configuration files, which are essentially everything that's back here. If anything over here changes, then you're going to have to reload the status. Systemctl enable essentially sets a service to start on boot, and systemctl disable essentially stops this, does the opposite of enable. It just prevents the service from starting on boot, or makes it so that the service does not start on boot. Are there any questions so far?
Just a general question about like processes. How are processes different from jobs? Like when I don't know if this is like the wrong terminology, but when I've like run jobs on some compute service before, like they've been characterized by PID as well, like just like a process.
Yeah.
So I wonder if there's a difference.
I think it's just an alternate name. It's terminology, yeah. Like they can also be called like workers. So it's like, oh yeah, like we spun up like like 8 workers, or whatever. It's like same thing. Yeah. Okay. And we can also look at another process, which is SSHD and handles SSH connections. Here, notice that for SSHD, currently your child processes are going to be bash and then htop, because htop is being run via bash. And as you're currently SSH'd into this machine, SSHD is running bash. So you just look at this hierarchy here and see where things start and how we go down by process. And PID 1 up here is usually just like the root process that starts when you first boot into the operating system. Another thing?
Um,
Okay. So there are also like a couple of examples of Nginx and HTTPD that I want to go over, which are both examples of services which listen on port 80 and serve content. So where in here does it say that? But okay, so there are two services that both will listen to port 80 and serve content. One is Nginx and one is HTTPD.
They do like the same thing.
And they pretty much do the same thing.
Yeah.
Probably you don't want both of them running at the same time.
Yeah.
Yeah, you definitely don't want both of them running at the same time. I think that was, I don't know why they have this here, but because this is just the same. Is there anything like if I scroll down? No. Yeah, this is essentially just like, don't run both services if they do the same thing, because then you're gonna get confused. Another potential thing is if you have your own Linux system that's not like a terminal, you might have like the display manager. Don't run like two display managers at the same time. That is not going to end well.
Yeah. Okay. I think the next slide is like alternative.
Yeah, there are also other alternatives to systemd, maybe with some compromised or limited functionality and some benefits. For example, Runit is a better init system than systemd because I said so. As it's minimal. You also can understand your services.
Okay.
Okay.
Are these your slides, Albert?
No, these are not. These are
Wait,
They-
who's the Reddit shell who added this?
I think this was like a while ago when like some person was like a big fan of Runit and essentially just created like an
Oh my God.
entire slide deck talking.
Okay. Anyway,
That was a Darsh. I warned you guys about that. I
the-
thought.
yeah, there's Reddit, there's like OpenRC, there's like SysV init, like there are many different like init systems.
Yeah, but
systemd is like by far the most popular. That's the one you'll probably use if you do like system administration. The other ones are like kind of weird and quirky.
those are just for like personal usage. They haven't really seen the production adoption that systemd has gotten, mostly because some of the services are not like some of the learning curve might be steeper or some other reasons. So anyways, yeah, did you?
Nothing to add.
Oh, okay, yeah, you can enable, disable, stop on boot, start on boot.
Oh yeah, but yeah, I guess this is like a good example. Like
These
this
are-
like, does not use like config files like systemd. So in this one you have to like create symlinks. Which have you guys
Yeah.
heard about symlinks? Yeah. Okay.
So essentially, like, if for people who don't know this, a symlink is just like you essentially just create sort of like an
It's like a desktop
alias,
shortcut in Windows.
sort of like an alias of like a program in a different location.
Yeah.
So it's like kind of like creating a shortcut to something from somewhere else. Yeah. Okay. But essentially, as we go here, we can see a lot of like the files in your service, so you can understand what exactly is going on. And there's no like, I think systemd uses sort of like a more structured configuration file, whereas this is just more raw bash
Like chain scripts
or
together.
raw, yeah, like raw shell scripting. So I guess that might appeal to some people who want to have the most minute control over every single thing in their computer. There's another example. Okay, this is just a propaganda at this point, but as Adarsh wrote, we should always prefer minimal simple software because it's readable, we can ensure that it's bug free, and it's simple. So have you ever done like the 61B thing, or not 61B, like 61A? I think no, 61B like build your own world. You could like create like a bunch of like really complicated code, and then you try to read it again, and then you're completely lost. You should always I don't entirely agree with like complete minimalism by function, but at least when you're trying to like write your code, you should think about like how can I do this in like the most simple way possible. And because just putting the extra thought in is going to save you a lot more time like when you're actually developing the thing. Or if you can't do like fully minimal because of readability, this may like readability is not always like the most minimal way to do things. At least make sure your code is like well organized and still small enough that it's not like you have a bunch of useless things, useless loose ends dangling around.
That's like, yeah, Unix philosophy. One thing only. Yeah, so it's like the fact that you have like multiple executables, right? Like you have one that's like really good at changing directories, or one that's like really good at like listing files or like searching for things, right? So it's like that, and then you like compose them together. It's like that, right? So you would do that with a init system, I guess.
Also, system T is
Okay, thank you.
like really bad.
Okay, that's the last slide. Let's wrap back around to the top processes.
Okay. Yes. Wait. Did you skip it or?
Yes, I skipped.
Oh,
Yes.
I don't know why I took over then, but
Yeah, I don't know. We can lecture together. That's fine.
but I think we should just start alternating slides.
Sure.
Okay, so what is a process? A process is essentially a single instance of a program. I think you asked about processes versus jobs. I believe this is the same definition as a job, essentially just one instance of a program that is being run at a certain time. They're usually isolated from one another and have their own memory, their own threads, etc. So usually like there are certain resources that are just allocated to a process, and then the process essentially does what it can with those resources. Except for Chrome, because they just
Yeah, I guess the main like differentiating factor is like processes cannot see each other's memory, but threads can. I think you learned that in 61C. It's also a popular interview question if you do like embedded or anything. So
yeah.
keep that one in your head.
You can also ask for additional isolation, like file system or network isolation. Yeah, you can do that. So a couple definitions. PID is going to be the process ID. PPID is going to be the parent's process ID. UID is going to be the user running the process, and then the program executable that the process is running
What?
is
Exec or something like that. Like
it contains these things.
CMD or exec will be like those two things. I don't know why it wasn't written, but yeah.
Yeah, and then the args, which are just the arguments of the process, and there are also other parts, but whatever. Yeah, I think that maybe skipping through this was not the best advised.
Yeah, my bad.
First process started at boot is given PID of 1, and that's going to be the init process and manages all other services and processes. You can also run htop and then open tree view. What is the root of the tree? I think you guys should just do this right now.
On your lab,
Like on your own.
not a bad idea.
Yeah.
Okay. Also, if you're on a Mac,
SSH.
yeah, no, you still have to press F5. Use like the globe key in like the bottom, like for like hold that and then press F5. It has a number, right?
Yeah, it has a number.
Yeah.
What do you think they have? What do you think they have touch bars?
I don't know. The touch bar was such a bad design idea.
I mean, tell Dell about it.
Look ahead. Hierarchy good. Reading ahead.
Bro, someone just looked, bro. That's crazy.
Okay, I don't know. It's like spoilers. Maybe we should like go back to the last slide.
Bro, there are also people like in the Zoom chat who are just like confused as to why I just skipped like 5 slides and skipped back.
Yeah. Well. Womp womp.
Okay, so has anyone opened up htop yet and sorted the tree? Let me just walk over and see what they're doing. Press F, open tree view. Press F.
Oh yeah, there you go.
I think it might be different if you're using that one. Can I see yours? You scroll all the way up. You sort the other way.
Okay, so one thing that's worth mentioning is that not everyone got a PID of 1. It's if you ran it on like a local machine or your or your like DeCal lab machine, you would get a PID of 1. However, if you were to run it on like any of these computers over here, this is not like you are not able to see any of the root processes because those are isolated away. So yours is actually going to have a different PID. But if you were to run it locally, it would look like essentially 1 first, and then you have a couple of other processes like SSHD, and then others. And then you can see that they kind of depend on each other like this. And yeah, the same for like Nginx, Tmux. Yeah. You have the shell running onto the state session. Like if you were to run a command in Bash, you would see like momentarily you would see like your command like pop up here and then it would finish. Right.
Yeah.
So yeah. I think this is yes. The fact there's a tree, I think you can infer that there are parent processes. There's PPID, so you can get the ID of your parent process.
Yeah.
Yeah. If you kill the parent process, you have orphaned process. I guess we'll get that later. Yes. So a process can start threads. If you've taken C61C, you know this. Basically, it's just like running many things at the same time, and they can also access the same memory. So yeah, again, threads can share memory. Processes cannot. Yeah. Aside, was this a Darsh again?
It
Oh,
probably
actually,
is.
this is not a bad question. Yeah. So, why do you think Chrome spawns so many processes?
Any like wild guesses?
Here are many websites open.
Indeed.
Indeed.
Because like the user's like clicking through a bunch of tabs, right? So like you can't just like wait for it to like start a new process, right? So like a lot of that has to just be running concurrently. Yeah. I guess they never put the answer here. But yeah.
Yeah, they're also spying on you. That's the OCF answer. Anyways,
Yeah.
So does Chrome like try to predict what website you'll navigate to?
That would be something to ask a Chromium developer. But I mean, it does cache things. And then yeah, I mean, it'll kill things that you haven't used for a while. So like if you haven't like opened a tab in like a day, but it's still open, it'll just like kill that process. And then like when you go back to it, it'll like have to start again. So yeah. I don't know about prediction though, maybe. But yeah, there's a thing called fork. That's how a process starts a new child process. It's like mitosis, except one of them remembers that it's the parent. And if the parent dies, then it orphans the child. Yes. Oh yes. A question. So yes, this is a program that forks and then it prints hello, as well as the ID. Any guesses? So like the program forks, right? And then it like it creates a child, right? Which runs the same code, right? And it forks, right? And then it creates another child, which forks. So
here's just the same logic.
Yeah.
Again, you have 3 forks this time, so how many hellos will get printed?
Yeah.
That's right, 2 to the 8th. Oh yeah, how many? Yeah,
Fork bombing.
how many of you have seen this line of code before anywhere?
It's like one of those like computer security jokes, like the like colon, semicolon, dash dash, like SQL injection joke. But this one is fork bomb. So
Okay, sometimes we want to make our child processes do different things compared to the parent processes. We can see this when like you have like one process that wants to essentially just like keep running bash while another one wants to like open, while the child process should like open neovim or something. Then you will say if the fork is greater than 0, then you do this parent process. Otherwise, you do the child process.
wait, did we not explain what a fork bomb is? Okay, sorry. I thought this slide was gonna explain it, but yeah.
Yeah, so essentially what this code, I think that this is a bit of a simplification, but essentially you are using a, you guys remember the bash scripting part, right? Were you guys there for that lecture? Okay, so essentially, if you want to look at it line by word by character, colon is essentially like just a stand-in name. Let's just write it out here. Colon is bomb. So then you have bomb, and then this essentially expands itself out into a function where bomb is equal to is a block of code that is bomb or bomb, or not or piped into bomb,
and then the and the end
And
you run in
then-
the background.
run it as a daemon. So essentially, this just spawns like exponentially many bombs. When one bomb is run, because essentially every time you run one bomb, the code of the bomb says pipe bomb into bomb, which essentially forks bomb into 2 other processes. And then each of these 2 other processes call bomb again, which forks them into 2 grandchild processes. So essentially, as you keep going, the number of child processes is going to like exponentially increase. And at the end, your system's just going to crash. It cannot handle that much.
It's like cancer on a computer.
Amazing. The cure for cancer on the computer is just to not run it.
It's a whole power button.
Hey, let's run it on your computer just a tad.
I heard the auto grader for like 162 got fork bombed before. Anyway,
Oh yeah, this is just
yeah,
HTOP again.
it's the thing you run to manage processes.
I think I told you guys all to run it. It's essentially like Task Manager on Windows, except like better, because it's good at it's good at like doing what it needs to do, but not necessarily as good as looking good. So and that's a good thing because you don't need your things to look good.
We're doing a very bad job separating opinion from fact in this lecture. Oh yes, this is an important thing. So these are different things that get displayed in HTOP. So some obvious ones would be PID user, like what the executable run was. If you guys like want to open it again, you can see all these fields. Like percent CPU use, percent memory use. The percent CPU use thing is like a bit of a, it's like calculated differently from like how you might be used to on Windows. Like you can have like more than 100% CPU used. So yeah, that's just like top things. And then time, I've actually not used that field, but I think it's like how long it's been running. Oh yeah, priority and niceness. So basically processes have this thing called a nice number, and that's like how often it'll be run. So like what actually happens like in the OS, if you take in 61C, you know this, but you have a thing called a scheduler, and it'll like schedule like when different processes are run, because it can only run so many instructions at once.
So like if you have like a higher nice number, wait, is it? I think it's actually lower nice number. Okay, so if you have like a lower nice number, it'll have higher priority. So like it'll basically schedule more. It'll schedule that process to run more often than other processes. So like if you have something like super like CPU intensive that you want to like put a lot of computing power into, like you would like increase the nice level. Okay. Vert res shared. I've never used those fields before. I don't know if you can elaborate on that, Albert, but
I don't think I've used these either. Yeah, I don't think I've used these either.
Google it. This is the real SysAdmin lesson.
Yep. Yeah, let's take a look real quick.
Oh my God.
Here we can just look it up.
Okay.
Okay. So essentially,
Go on to the answer.
the virtual image is going to be the total amount of virtual memory used by the task. And this includes all code, data, and shared libraries, plus pages that have been swapped out and pages that have been mapped. So if you don't know what like virtual memory is, it's better explained in like 61C or 152.
Yeah, basically it's like fake memory. Like
it's just
you have like the 16 gigs of RAM on your computer, right? But like your computer can also like copy some of that like onto your disk to like save space. Like so like the more recently used stuff will like be in memory, and then it'll like copy older stuff onto your like SSD. So virtual memory is like all of that, like the stuff on your SSD, like in what's called swap space or in your like actual RAM.
I think another benefit of virtual memory is like if you have like different like if your RAM is not as well fragmented, like sometimes it can like move like different pages that are in disjoint locations in the RAM into one unique into one like contiguous virtual page, right?
Yeah.
Okay, and then swap. This is essentially swap size. Res is the resident size, which is the non-swapped physical memory that a task has used. So this is like the amount like in your 2 RAM sticks that is currently in use by this process. And then shared memory size is the amount of shared memory used by a task, which is essentially reflecting the memory that could be potentially shared with other processes. There are, if you want to go more advanced, I can put this on the. There are other markings. I can just put this on the.
I mean, you can just like pull up the man page, but
yeah, you can also. Yeah, if you want something to take a look at first, I guess this is it. Wait, I can't edit it. Whatever.
Click the slideshow button.
Okay. And back to scheduled programming. Zombie processes. So essentially, processes can die, which means they essentially just stop running, but they have to be, their memory has to sort of be reallocated back into the system. Which means that like they've not and reaping is essentially, I think, the process of like freeing all of the things that a program has used after it dies. So a zombie process is essentially just taking up like useless space without like taking up space in the process table without actually doing anything. And usually the reason for this is so that the parent process can collect the exit status. And this is completely normal because all children that end up exiting are going to become zombie processes, at least for a while.
Yes. Funny
Yeah.
Stack Overflow. Oh.
Okay, are there any questions so far on anything that's been discussed? For a lot of this, like if you want to know like the greater specifics, I think that an operative CS class in the 150 or 160 series is probably going to help you a lot more than like we can do here. But for any like basic questions about what's on the slides, do you guys have any questions?
For niceness, I guess for scheduling, is niceness calculated based off like the estimated computational load other process?
I think it's just like I'm not really sure like if it's a thing that's calculated. Like you just like put you like set the nice level of the process, and like it'll just be prioritized based on that. With like 0 being like technically the highest, but you can actually go into like negative numbers, like above 0 in priority. Although I don't think any system processes will do that. But yeah.
Yeah, zombie
And
process
I think the like priority is just linear. I'm not sure if it's like anything more than that. Orphan processes. Did we skip
Okay.
that? Oh yeah.
Yeah. So when a process dies, do you want to talk about this or should I?
I mean, yeah, like if you kill like a parent process, and, like the child process is still alive, it's called an orphan process.
Oh wait, I think that we're still on
Oh,
to
the
the
exit codes.
exit codes. Yeah.
Oh, yeah, okay. So basically, when you kill a process, it'll return or when a process kills itself, which it's supposed to do, it'll return an exit code between 0 and 55. 0 means like if you ever like run a program and it's like exit code 0, that's like what it's supposed to do. 0 means that something went wrong. Anything from 1 to 255 means that something did go wrong. Usually 1 will mean like a panic or something like that. So, and anything else? You should move the.
Oh my god. Yeah.
Yeah, but yeah, 0 means like your program exited successfully, like it was supposed to exit, and then yeah, anything else is error.
Okay, and then yeah, so like 120, like an exit code like 1, 2, 3 over here is going to be an error. If the parent exits first, then this is where we start talking about orphan processes, which I think Michael has been hinting about for like the past like 10 slides.
I thought we were gonna anyway. Yeah, basically, if you kill a parent process, like all the children processes just get reclaimed by the system process. So, yes.
And then if any orphans are zombies, then the init also frees up their space. So first of all, when can zombies become a problem? First of all is when the parents do not wait for their children first. Second is the parent is a long-running process. And the third is that zombie child processes never become orphans, in which case we have resource leakage. So essentially, if like the parent,
if like okay, I guess an example like I could give would be like if you had like maybe a thing that like spawns many workers, right? Maybe something like super computationally intensive, so you want to like take up multiple processes, right? And then like those workers finish like whatever they're computing, and then they don't exit, right? They're just like sitting there like hogging memory, and like if you spawned like tons of them, like you're just wasting resources. And because like if the parent is just like sitting there waiting and like not telling the children to exit, then yeah, it's just wasteful. So that's what's meant by resource leakage.
or then it doesn't wait and also just keeps running and doing its own things. So it never actually checks on whether its children are have terminated or not. So essentially, this is just like if you never check for your child process to see if it's stopped or not, you're never going to try to reap its data. And as a result, you're going to have a bunch of zombies that are just not orphaned, and therefore will also never be reaped by the initial init process. Because if the parent exits, then any orphan processes are going to be reparented, and the init is always watching, so it will know when any process dies. And now we talk about inter-process communication, which is essentially the various ways in which multiple processes can communicate with each other. So the first is going to be exit codes, signals, pipes, sockets, and the message bus, such as dbus on Linux. There are also a lot more that we're not going to talk about. First, signals. So sig term essentially is going to tell a process to exit now. Like if you've ever been on like your terminal and you're running like something and it just didn't stop, and then you press Control C, that is a sig term. In that you are just waiting for, you are just like doing nothing and just waiting for the thing to terminate. Second sig kill is going to
Terminate.
terminate the process immediately, without like waiting for any like
Cleanup or anything.
cleanup or
Yeah.
anything. Sig in is going to actually wait. Shit. Sig term is not sig in. My bad. I screwed up. Sig in is interrupt when you press Control C. Sig term is essentially any like signal from anywhere that tells the process to like exit now. And wait for cleanups. Int is between term and kill in that it tells the process to terminate, but doesn't immediately stop them without any cleanup. Usually there's still some error handling in response to a SIGINT, but it's not as clean as if it was told to just exit and just do it. Just exit without asking them like to do it like immediately. But it does also interrupt processes, so you have to be careful if you're running any long things. Like if you're updating your system on your terminal, which in like Ubuntu or like any other Linux distribution you usually end up doing, you probably don't want to interrupt that because it could lead to your computer being in not necessarily a good state. Usually there's cleanup for this in that they download everything first and then try to install it. But again, it's not necessarily perfect. Just don't sig in if you don't need to. Sig hangup or sig hup is when the user closes the terminal window. So yeah, in this case, like there's always like a warning before you close like the window of your terminal. But if you end up doing that, any process that's running in the terminal is going to get a sig hangup,
which they can handle differently.
Which they handle differently than
some things like Vim, for example, will just like close. But like some things, I honestly can't give a good example, but like there are things that, like will just keep running in the background if you like close the terminal. So an example of, have you guys used a NoHup? There's a tool called No Hangup where it'll run the process and then like coerce it to like keep running basically. So it will not send the process like NoHup is what you prefix the process with, and it will receive the sig hangup and it will choose actively not to hang up. So that's like one way around it. There's like a command for that.
And there's also sig win change or sig winch, which means that the window size has changed. So whatever process you're doing, like if you have like a progress bar that's supposed to take the whole width of the terminal, if the window size changes, then the width of your progress bar should also change with it.
Yeah, another example would be like HTOP or Vim. Like if you drag the window, like it doesn't just keep the same size; it'll like resize itself. So, yeah.
And then sig stop and sig cont is like stopping and resuming a process. Do you know any?
I've not used these before.
Yeah.
Like the top 5 are probably the most common ones that I've seen.
Yes, but sig kill and sig stop cannot be handled in any situation. Sig kill means you are dead. They put a gun, they shot it. They weren't even asking you to kill yourself. You are dead. And then serve it. Okay, we're back to where we started.
Yes. This yeah.
What do you mean by cannot be handled?
You cannot like write something in your code to say, if I was killed, do this. Because it's like you write like, it's like essentially you're saying, oh, once I die, I'm gonna go and travel the world. You cannot travel the world when you are dead. Maybe your ashes can, but you can't. So it's the similar thing. You cannot
it's like being told like you have 6 months to live versus, I guess that's the best analogy.
Yeah.
Like you like one of them, like handleable means like you can like clean things up. So like let's say you have like a, I don't know, like some like user program, right? And you receive like a sig term, right? To just terminate the process. So that would be like maybe you're like still, I don't know, like copying some file or like doing something. It's like maybe you can like finish those things up, right? Like maybe you can like write any changes to like your configuration file or like your cache, right? And then you like gracefully hang up, right? Whereas if you're killed with like a sig kill, you just like it just stops the program. Like whatever like instruction the CPU is executing, like boom. Like no chance to
There's no chance for like a soft landing. You just
die.
Which
is why I think in general like sig kill, it's like recommend that you like not use it super heavily because like it can cause like data corruption and stuff. Like if something's like not finished copying or something like that.
Yeah. I mean, usually if you have like a terminal process, most of the time like Control C should work.
if it's so like broken that it cannot like respond to like a SIG.
This happens sometimes. So
If
you
it
have to
can't-
sometimes.
Yeah, sometimes if you cannot, like, if it's so broken it just can't respond to a SIG int, it's probably so broken that it's not even running anything of worth to begin with. So you might as well just kill it or like hang up the window or something. Yeah,
I think it's pretty much all. Yeah.
I think that's all for today. Do
The
you?
lecture. I mean, this is a lab.
I mean, yeah,
We're here to
today.
help with the lab. Here.
I keep forgetting that there is that
Yes.
there's like more after the lecture for
There's
the
a lab.
things. But there is a lab. So yeah, we will be around. I have a project due at midnight, so I will be slightly less around.
Yeah.
But yeah, if you guys have any last questions, any like comments, or any like concerns about like logistics, even just feel free to ask now. Or
asking about
sometime
logistics. I'm like
or sometime in the next like hour or so.
Yep.
All right, should I end the Zoom call now?
yeah.
All right.